Okay. So in the last class, we have discussed this non-relativistic limit of Dirac particles. So from that, we can see that magnetic moment of the electron automatically emerges. Okay. So this is the electric field in terms of scalar potential and magnetic field in terms of vector potential. Those are the representatives of electric and magnetic fields. Then we discussed the Dirac equation. Okay. And I think we have reached here. So this psi 1 psi 2 means this phi can be taken as the positive energy, spin up and spin down states, and chi can be taken as the negative energy, spin up and spin down states, like that. So phi and chi are the positive and negative energy states with two components. So the total components is again 4. Now we have wrote the Dirac equation. Then we wrote the positive energy state as well as negative energy state in terms of the other states. So this is positive energy state in terms of negative energy state, and this is negative energy state in terms of positive energy state. Okay. Then we applied the non-relativistic condition, non-relativistic limit. We put we can neglect that this E dash minus E phi is very small compared to 2 mc square. So in the above two equations, we can write chi n phi as like this. Chi equal to phi divided by a very big quantity mc. So we can assume that phi is very large. Okay. For the positive energy states. So phi is the positive energy state. So in that case, chi is very small. Similarly, in the case of negative energy states, chi is very large, but phi is very small. Okay, chi is very so chi and phi and chi are the positive and negative energy states. So okay, now again take substitute 159 in 55. Okay, 59 is this one expression for chi. That is, you substitute that in 55. 55 is this equation. In this equation, you substitute for this chi. So all the terms becomes in terms of phi. If you substitute for this chi, okay. So we get E minus E phi equal to C into sigma dot P already. Now this is chi. Substitute for chi. So all the terms, three terms, phi comes. Mc square phi. Now this can be written as, let this mc square come to the left side and E phi goes to the right side. So E minus mc square phi equal to sigma dot P. Into sigma dot P you can write sigma dot P whole square divided by 2m. C cancels. Then E phi all into phi. Okay. Now we can simplify this sigma dot P whole square like this. We know this identity in last semester. We have already did this. Sigma dot A and sigma dot B equal to A dot B plus I sigma dot A cross B. I think you remember this. This is an identity which can be asked to prove in examinations. Okay. So important identity. In this identity, you substitute for A and B as P. A equal to P and P operator and B equal to P operator. So this becomes sigma dot P whole square. That means P dot P, that is P square, plus I sigma dot P cross P. Okay. Now normally P cross P is 0, but we have to introduce the magnetic interaction also. So after introducing magnetic interaction, what is the result of P cross P? So now you introduce, change all this P into P minus E by Ca. That means we have introduced the magnetic interaction also. Previously we have introduced the electric interaction with E minus E phi. This actually this E phi, this one is by the is for the represents the electric interaction. Now you add the magnetic interaction into our theory, so that you can this P you have to change into P minus E by Ca. Here also P, all the P's on the RHS you have to change into P minus E by Ca. So let us see what is P cross P. After the magnetic interaction, P cross P becomes P minus E by Ca cross P minus E by Ca. This is not necessarily 0 because these are operators. So we have to take care. Now you multiply, 4 terms will come. Out of this, P cross P becomes 0, A cross A becomes 0. Now what remains is P cross A and A cross P. Out of these 4 terms, 2 terms become 0, same cross product, same quantity cross products are 0. So finally this becomes minus E by Ca, E by C is common. Then P cross A and A cross P plus A cross P. Okay. Now, is that clear? Now this can be simplified and written as minus IH cross B. That is given in the footnote. You can see that. See P cross A and A cross P. Okay. In order to simplify, you put on the RHS SI. Then finally you can remove that psi. Okay. Then this becomes P cross A psi plus A cross P psi. Now you put the representation for P as minus IH cross del. Okay, coordinate representation. Then you can see that you can go through the simplification, and finally you can see that this del cross A will come. Del cross A is nothing but B. So you get minus IH cross B psi. Now remove psi, so that you get IH minus IH cross B. That you can substitute it here minus IH cross B, so that again this simplifies into minus minus cancels, IH cross E by C into B. Okay, that is this uh, P cross P. Okay, this one. Now you simplify what is P square after introducing uh, or you can substitute for in this equation. This P cross P you can substitute here. So sigma dot P square equal to, you substitute here also, P minus E by C A whole square plus I sigma dot this quantity P cross P, IH cross E by C into B. Okay, now this can be written as P minus E by Ca whole square minus this 2I comes, so minus comes, I square is minus, so EH cross by C into, all these are constants, then sigma dot B. Okay, so this is sigma dot P whole square in the non-relativistic limit. So substitute this sigma dot P square here. Substitute sigma dot P square here, so that this equation 61 becomes E minus MC square phi equal to this quantity divided by 2m plus E capital phi, all acting on small phi. Okay, so you substitute this one here, so that becomes divided by 2m, only reference is divided by 2m, then plus E phi into phi. Okay. So this E minus MC square, you may call it as E prime, no problem. So this E prime, you can write it as IH cross dou by dou t equal to this quantity. Okay, so this equation is actually now we obtained this equation in relativistic quantum mechanics when we applied non-relativistic limit conditions. So that means we went back into the non-relativistic quantum mechanics, which is our earlier what we studied in last semester. So in this equation is actually is a Pauli equation of the electron. Actually, we didn't studied this, but this is actually a famous equation, Pauli equation for the electron, which was postulated by, not derived by Pauli in the framework of non-relativistic quantum mechanics. Okay, and the second term, the sigma dot B represent the potential energy. So this is actually kinetic energy, P square by 2m kinetic energy. This term actually represents the potential energy associated with a magnetic dipole moment. Okay, so this one EH cross by 2mc into sigma, which is nothing but the mu b, Bohr magneton into sigma. So whatever in this bracket term is Bohr magneton. Okay, so Bohr magneton arrives when the electron is or when the atom is subjected to magnetic field. Okay, atom is a tiny magnet. So when you apply external magnetic field, it tries to align that magnetic field. Then you get you can see the magnetic moment of the electron inside an atom, which is the Bohr magneton, which is the smallest unit of the magnetic moment due to an atom. So we get the same thing here also. So Bohr magneton automatically comes in this theory of relativistic quantum mechanics. That is why when we applied non-relativistic limit, we obtained the same expression as introduced by Pauli. Okay. So these results are in agreement with the observed magnetic moment of the electron. Thus, the above equation shows that Dirac particles are electrons, at least positive energy particles, positive energy electrons inside an atom. So Dirac particles are nothing but electrons. Okay, that is the result what we obtained from applying the non-relativistic limits. So this again shows the validity of the theory, relativistic formalism. The theory is valid. So when we apply non-relativistic limit, we go back to our previous theories put forward by Pauli et al. Okay. So that is the end of the syllabus. Now you can try these problems. These are very easy problems. You can easily do. Now actually, let me stop here for recording.